If you watch a mountain over a timescale of millions of years, it doesn't stand still. Through a continuous process called gradation, massive, jagged peaks are worn down and eventually leveled into flat plains. To understand how a mountain disappears, we need to look at the first two steps of the process. This table breaks them down into weathering and erosion. Weathering breaks apart rocks right where they sit. Erosion happens when that broken material is carried away. People often mix these terms up, but they are a partner demolition team. Weathering swings the sledgehammer to crack the foundation, and erosion drives the dump truck to haul the debris away. The most efficient dump truck on Earth is a river. This diagram maps a complete river system, acting as a continuous conveyor belt from high mountain peaks down to the ocean. Up near the source, water flows rapidly down steep inclines. It picks up loose rocks and drags them along the riverbed. This process, called abrasion, uses the rocks like heavy grit sandpaper to cut deep, narrow trenches directly into the earth. As the river reaches flatter ground, the water slows down. It loses the kinetic energy required to carry heavy rocks and sediment, so it drops them. We call this deposition. Over thousands of years, this accumulated material builds wide, fertile plains. This diagram of coastal features illustrates a different action, water striking the shore horizontally. The continuous pounding of waves fractures headlands, hollowing out sea caves and eventually punching through to create stone arches. This photograph reveals a third, hidden method. Rainwater seeps below the surface and chemically dissolves soluble rocks like limestone, slowly excavating massive underground caves. Water is a highly versatile tool. It slices vertically through mountains, hammers horizontally at the coasts, and dissolves the ground from the inside out. Liquid water takes thousands or even millions of years to reshape a landscape, but gradation doesn't always operate on deep geological time. Before we look at fast changes, let's look at the slowest. This photograph captures the path of a glacier. Glaciers are massive rivers of solid ice. They move at a crawl, but their immense crushing weight allows them to literally bulldoze entire landscapes, grinding bedrock into fine powder. Contrast that with what can happen in 10 seconds. Look at this collapsed road. When heavy rain or an earthquake loosens a steep slope, gravity takes over immediately. A landslide moves millions of tons of earth in a single violent rush. Let's test how these different tools leave different marks. If you find a valley shaped like a sharp V and another shaped like a wide U, which one was carved by fast liquid water and which by slow, heavy ice? The sharp V is the work of a fast-moving river cutting downward. The wide, flat U was scraped out by the wide, heavy base of a glacier. From the slow grind of a glacier to the sudden rush of a landslide, the movement of the Earth's surface follows a single direction, down toward the lowlands. You don't need a mountain range to see this process in action. You can observe the entire cycle in your own neighborhood. Next time you walk outside, look for cracked pavement or a crumbling brick wall. That is weathering, the earth breaking apart right where it stands. If you go out right after a heavy rainstorm, look at the runoff. That muddy water carrying grit down the street is erosion. When that water pools and the dirt settles at the bottom of a puddle, you are watching deposition. To summarize, water, wind, and ice apply the force. The material breaks, moves, and drops, and it happens at speeds ranging from a million-year glacier to a 10-second landslide. The Earth's surface is a workspace in constant motion, continuously dismantling highlands and using the debris to build new foundations somewhere else.